Hello. In this video, I am going to walk you through an animation of the cardiac cycle. You'll find this in Blackboard in our Lecture 20 lecture folder, and it's called Overview of the Cardiac Cycle. There we go. So this is a very helpful animation, both in terms of understanding the structure of the heart, the anatomy, but also the function, the physiology of the valves. Think about it. What opens and closes the valves? Is it muscle? Is it an electrical charge? Well, actually, it's pressure. As the chambers above, the atria up here, we're looking here, of course, at the right atrium. When the right atrium contracts, it generates positive blood pressure, which squeezes blood through the already open tricuspid valve. This valve is named for the fact that it has three tiny leaflets that look something like white rose petals. They blow open when the pressure is higher above and blood is moving through. And then they blow closed when the powerful right ventricle below contracts and there's suddenly an inversion of pressure, right? Suddenly there's higher pressure below than there is from up above. So when we watch the video, especially focusing on this bit right here, it might be easy to imagine that these little muscles are somehow pushing the valves closed. But remember, these are actually safety lines to prevent the valve from blowing open the wrong way. The blood pressure is actually so high here in the right ventricle that there is a slight chance that this tricuspid valve could prolapse. That's a term that means it goes where it shouldn't be, right? It goes beyond its normal physiological range. But look at this. Nature has evolved safety strings. These are the tendinous cords, sometimes called chordae tendineae, and these are the papillary muscles, which give a little tug to those cords at just the right point to prevent the valves from breaking. And then you get a little saloon door swinging both ways, and that would be bad, right? Similar arrangement up above. Here, of course, we see the pulmonary semilunar valve opening. You don't have to use the word semilunar every time. You should know what that means. It means half moon. So these are structurally quite different from the atrioventricular valves below, the semilunar valves, including the pulmonary and aortic, which would be in the background up somewhere in here. These are both shaped like half moons, and so they're called the semilunar valves. The function is very much the same. The semilunar valves also open and close due to pressure. There's the aortic valve there. We'll come back to it in just a minute. What do we see right here? This is, of course, freshly oxygenated blood returning from the lungs and flowing into the left atrium here through the pulmonary veins. Moving back here just for a quick moment, do you recognize this valve here? This is the right ventricle below. This is, of course, the pulmonary semilunar valve. That makes this the pulmonary trunk. And then the left pulmonary artery going to the left lung, the right pulmonary artery going to the right lung. Now we see the return from the lungs. Remember, generating blood pressure is the most important function of the heart. So why is this blood going to and from the lungs? Of course, high blood pressure. I don't mean that in a pathological sense or a disease-related sense. This is normal, positive blood pressure, circulating blood through a tissue, and we call that process perfusion. So the lungs have been perfused, and we're now collecting that freshly oxygenated blood. What chamber do you think that blood is flowing into? That's right, it's the left atrium. When the left atrium contracts, it opens this valve here, bicuspid or mitral. Now, clinically, mitral is much, much more common, but of course, like so many things in this class, you got to know that this has many names. It is the mitral valve. It is also the bicuspid valve. It is also the left atrioventricular valve. Here's the most powerful chamber of the heart, ladies and gentlemen. This is the left ventricle. When the left ventricle contracts, it generates very high blood pressure, forcing the aortic valve open. And notice that the aorta has to expand quite quickly. Looks like the little throat of a frog, right? It's really swelling. By that, I mean that the aorta is very extensible, stretchable, and it is very elastic. And that's an important characteristic. The elasticity, which allows the aorta to snap back into position, is what pushes these, generates positive blood pressure above the aortic valve and then slams these aortic valve leaflets shut. So to be clear, the purpose of any of these 4 valves is to prevent backflow. All of these, each of these, is opened by blood pressure and closed by blood pressure. And you probably know that this closing is what causes the heart sounds, right? Lub-dub, lub-dub, lub-dub. That's really, we're just listening to the closure of those heart valves. Well, I hope that was helpful.